Introduction to Trigonometry. The theorem of Pythagoras, it states, in any right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. In the diagram, capital B is angle 90. In that right angle triangle ABC, the side facing the right angle is small b. The other two adjacent sides are side C and small a. So b square, which is the hypotenuse, the square of on the hypotenuse, b square, equals to sum of the squares on the other two sides, that is a square plus c square. Let's take an example. Two aircraft leave an airfield at the same time. One travels due north at an average speed of 300 km per hour, and the other due west at an average speed of 220 km per hour. Calculate their distance apart after 4 hours. The solution. Now, the first one travels at average speed of 300 km per hour. The distance will be 4 times 300. 4 times 300 is time times speed equals to distance. So 4 times 300, that gives 1,200 km due west. It travels due north, that's 1,200. The distance due north is 1,200 km, and the other one due west at the speed of 220 km. The distance for that 220 is 4 times 220, which is 880 km due west. So the angle between them is 90 degrees. So using Pythagoras theorem, let's go to page 2. Using Pythagoras theorem, we notice that BC square is 1,200 square plus 880 square, and that's solving. BC is square root of 22,14400. That gives 1,488 km. Example 2. Find the value of x. Find the value of x in this right angle triangle below. X plus 2 is the side facing the right angle. So x plus 2 squared is equals to x plus 1 squared plus x squared. And that gives expanding. You have x squared plus 4x plus 4 equals to x squared plus 2x plus 1 plus x squared. That's collecting like terms. We have x squared minus 2x minus 3 equals to 0. Factorizing x minus 3x plus 1 equals to 0. X is 3 or minus 1. Since our x, the value cannot be negative, x equals to 3. Now, let's look at page 3. Is an assignment on Pythagoras theorem. Assignment on Pythagoras theorem. The first one says two ships leave a port at the same time. One travels due west at 18.4 km per hour and the other due south at 27.6 km per hour. Calculate how far apart the two ships are after 4 hours. The answer is 132.7 km. 2. Triangle PQR is isosceles. Q being a right angle. If the hypotenuse is 38.47 cm, find A, the length of side PQ and QR, and B, the value of angle QPR. And the solution, 27.20 cm for A, and for B, the angle is 45 degrees. Then you have to determine the length of DE in the diagram for question 3. On page 4, trigonometric ratio for an acute angle. Trigonometric ratio for acute angle. An acute angle is an angle that lies between 0 and 90 degrees. In that diagram, ONP, let's use ONP. N is angle 90. The capital N there is on angle 90 degrees. Now, if ON is X, PN is Y, and OP is R, using SOHCAHTOA, sin theta is opposite over hypotenuse, which is Y over R. Cos theta is adjacent over hypotenuse, which is X over R, and tan theta is opposite over adjacent, and that gives Y over X. Cosec theta is 1 over sin theta, which is R over Y. Sec theta is 1 over cos theta, which is R over X. Cot theta is 1 over tan theta, which is X over Y. Also, tan theta can be written as sin theta over cos theta, and cos theta can also be written as cos theta over sin theta. Let's look at page 5. Furthermore, in figure 1, in that diagram, using Pythagoras theorem, you have x squared plus y squared equals to r squared. Dividing through by r squared, we have x squared over r squared plus y squared over r squared equals to 1. X over r is cos, y over r is sine. So cos squared theta plus sin squared theta equals to 1. That's the first trig identity. We can also write sin squared theta as 1 minus cos squared theta. Dividing equation star also through by x squared. So we have 1, that gives x squared over x squared, which is 1, plus y over x squared equals to r squared over x squared. Y over x is tan, so 1 plus tan squared theta equals to sec squared theta, because r over x is sec. So that gives equation 2, which is on the second trig identities. Similarly, dividing equation star through by y squared, we have x squared over y squared equals to y squared over y squared. Y squared over y squared is 1, so x squared over y squared plus 1 equals to r squared over y squared. X over y, which is cot, 1 plus cot squared theta equals to r over y is cosec. So 1 plus cot squared theta equals to cosec squared theta, equation 3. The relationship 1, 2, and 3 enable us to calculate all the trig ratios of all the trig ratio. If one is known, if one of the ratio is known, we could get all the remaining 5 trig ratios. Now let's look at example on this. On page 6, if sin theta is 1 over root 3 and theta lies between 0 and 90 degree, theta lies between 0 and 90 degree, find the values of the other trig ratio. You have to find the value of the other trig ratio. Now let's look at the diagram. So opposite over hypotenuse, the opposite is 1, the hypotenuse is root 3. Of course, we can get the adjacent. Let x represent the adjacent. So using Pythagoras theorem, root 3 square equals to x square plus 1 square. So 3 minus 1 gives x square. X is root 2. So sin the adjacent x equals to root 2. So cos theta is adjacent over hypotenuse, which is root 2 over root 3. It can also be written as root 2 over 3. Cos square theta, we can also use cos square theta equals to 1 minus sin square theta. So 1 minus sin square theta is 1 over 3. So cos theta is root 2 over 3. Tan theta is sin theta over theta. Sin theta over theta. Of course, if you use sin theta gotten that 1 over root 3 divided by cos theta. Cos theta is root 2 over 3. And if you simplify that, you have 1 over root 2. We can also use opposite over adjacent. The opposite is 1 and the adjacent is root 2. Tan theta is opposite 1, adjacent is root 2. Sec theta is 1 over cos theta, and that's root 3 over 2, square root of 3 over 2. Cosec theta is 1 over sin theta, and that is the inverse of sin theta. Sin theta is 1 over root 3. The inverse of that is root 3. Now let's look at page 7. On page 7, if x is a cos theta, we are asked to simplify a square minus x square. A square minus x square is a square minus a cos theta all square. A square minus a square cos square theta. You can factorize a square out. If you take a square out, you have 1 minus cos square theta, and that gives a square sin square theta, since 1 minus cos square theta is sin square theta. So you have to solve the assignment. If cos theta is 12 over 13 and theta lies between 0 and 90 degrees, that is, theta is an acute angle, you have to evaluate sin theta, tan theta, cot theta, sec theta, cosec theta. 2. If tan theta is 3 over 2, find the other 5 trig ratios. And 3, point A lies at the coordinate 2, 3, and B lies at the coordinate 8, 7. Determine A, the distance AB, B, the gradient of the straight line AB, and C, the angle AB makes with the horizontal. Now let's look at page 8. On page 8, I have on page 8, proving trigonometric identities. Proving trigonometric identities. Trigonometric identities may often be proved by reducing one expression, usually the more complicated, to this second, or showing that left hand side minus right hand side is 0, or showing that left hand side over right hand side is 1. Now let's take the first example. Show that tan theta plus cot theta equals to sec theta cosec theta. Now the left hand side, tan theta is sin theta over cos theta, and cot theta is cos theta over sin theta. Now simplifying, the LCM is cos theta sin theta. Cos will go there, we have sin times sin is sin square theta. Sin will go into the LCM, we are left with cos. Cos multiplied by cos gives cos square theta. So sin square theta plus cos square theta is 1. So 1 over cos theta sin theta. I can write it as 1 over cos theta multiplied by 1 over sin theta. And 1 over cos theta is sec theta, and 1 over sin theta is cosec theta. That is the right hand side. Now on page 9, so you have to show that 1 plus sin x divided by 1 plus cos x into 1 plus sec x into divided by 1 plus cosec x equals to tan x. The left hand side can also be simplified as 1 plus, you can simplify the left hand side. So that left hand side, if you simplify it, you have 1 plus sin x divided by 1 plus cos x into 1 plus sec x is 1 over cos x divided by 1 plus cosec x. Cosec x is 1 over sin x. So that gives 1 plus sin x divided by 1 plus cos x into cos x plus 1 over cos x, that's the numerator, divided by the denominator, which is sin x plus 1 over sin x. I can turn division to multiplication by taking the inverse. So that third line gives 1 plus sin x over 1 plus cos x times 1 plus cos x divided by cos x times, instead of this time being the denominator, we'll change it to numerator. I turn that division to multiplication. That gives sin x over 1 plus sin x. And if you simplify, this reduces to sin x over cos x, which is tan x, and that's the right hand side. Of course, let's look at the next example. Show that sin phi over 1 minus cos phi equals to 1 plus cos phi divided by sin phi. I want to use left hand side over right hand side equals to 1 in this case, because it's not easy to simplify the left hand side to get the right hand side. So left hand side over right hand side, sin phi over 1 minus cos phi multiplied by sin phi divided by 1 plus cos phi. Because if I take the right hand side to the other side, if I cross multiply, I will get sin phi over 1 plus cos phi. And then when you multiply, I have sin square phi divided by 1 minus cos square phi. Of course, 1 minus cos square phi is sin square phi. So sin square phi over sin square phi is 1. Now the assignment, you have to show that sin square theta plus 1 plus cos square theta, 1 plus cos theta all square equals to 2 into 1 plus cos theta. Then 4 minus 3 cos square theta equals to 3 sin square theta plus 1. Now let's look at page 10. On page 10, I have a series of assignments. 1 plus cos theta over 1 minus cos theta times sec theta minus 1, sec theta plus 1 equals to 1. 4 sin theta plus cos theta all square plus sin theta minus cos square theta all square equals to 2. 5 cos 4a minus sin 4a equals to cos square a minus sin square a. 1 minus sin theta, 1 plus sin theta equals to sec theta minus tan theta all squared. You can see 7, 8, and 9. Because students should solve those. You should solve the assignment in an exercise book and submit when we meet. Now let's look at page 11. Page 11. On page 11, I have the quadrant. Page 11 deals with the quadrant. The quadrant, we have 4 quadrants. The first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. The first quadrant lies between 0 and 90 degrees. The second quadrant lies between 90 and 180 degrees. The third quadrant lies between 180 and 270 degrees, while the fourth quadrant lies between 270 degrees and 360 degrees. Of course, in the first quadrant, I put A there. That capital A indicates that all the trig ratios are positive in the first quadrant. Sine is positive, cosine is positive, tan is positive, and then cos is also positive in that first quadrant. But in the second quadrant, I put x. X indicates that only sine is positive there. And in the third quadrant, I put capital T to show that only tan is positive. And of course, in the fourth quadrant, I will use capital C to show that only cosine is positive. Now, if you look at the first quadrant, we have theta there. That's the angle lie between 0 and 90 degrees. In the second quadrant, I'll use the formula 180 minus theta. And in the third quadrant, we use the formula 180 degrees plus theta. And in the fourth quadrant, we use 360 minus theta. Let's look at example 2 of this. Now, evaluate sine 150 degree cos 210 tan 300 cos 420 degree. Now, the solution sine 150 degree can also be written as sine 180 minus 50. Of course, 150 degree is in the second quadrant, and that gives sine 30, which is 0.5. Of course, we could also use, instead of 180 minus 150, I can use sine 180 minus theta, if theta is taken as acute angle. So 180 minus theta is sine theta. So, and that gives sine 30 degree. That's another formula, which is 0.5. Sine 30 is 0.5. Cos 210. If we use 210, if you take note, 210 is in third quadrant, and the formula there is 180 plus theta. So 210 can also be written as cos 180 plus 30 degree. So, and that gives cos 30 degree, which is, but because cosine is negative in that third quadrant, our answer is minus 0.8666. Is negative in the third quadrant. Cos 210 is negative in the third quadrant. Now, in the third one, tan 300. 300 is in the fourth quadrant between 270 and 360. So 300 can be written as minus tan 360 minus 300. Of course, because the angle is in the fourth quadrant, and that gives minus tan 60 degree. We could also use minus tan 360 minus 60 degree if we take theta as an acute angle. So 360 minus 60 is 300, which is minus tan 60 degree, which is minus 0.1732. And cos 420 degree, cos 420 degree is cos 360 plus 60 degree, which is cos 60 degree, and that gives 0.5, because 420, of course, is more than 360. So adding or subtracting a full rotation to an angle does not change the value of the angle. So 360 plus 60 is 420. And of course, cos 360 plus theta is cos theta. Now let's look at example 2. You have to evaluate, you have to write in terms of trigonometry ratio of positive angles the following: cos minus 170 tan 210 cos 300 sine minus 500. Now on page 12. Let's look at page 12. On page 12, I have on page 12 the solution. But before the solution, let's consider negative angles. So if you move in the anti-clockwise direction, you have positive angle, and if you move in the clockwise direction, you have negative angle. That is starting from the x-axis, taking x as the origin, 0 degree there. If you move from x-axis upward, you have positive angle. If you move downward, you have negative. Now, sine minus theta is minus sine theta. Sine of a negative angle is negative, cosine of a negative angle is positive, and tan of a negative angle is negative. Now, the example, cos minus 170 degree is also positive, which is cos 170. And 170 lie in the third quadrant, which is 180 minus 170. So minus cos 10 degree, that's its equivalent. Now, tan 210 degree is tan 180 plus 30 degree. 210 is in the third quadrant, which is tan 30 degree. Cos minus 300 is cos 300 because it's negative angle, and 300 is the fourth quadrant, which is cos 360 minus 300, which is cos 60 degree. And of course, we could use cos 300 could also be written as cos 360 minus 60 degree, which is cos 60 degree. Sine minus 500 minus sine 500, because it's a negative angle, I have sine 360 plus 140 will give us 500. And because 140 there, we have negative angle, 140 is in the second quadrant, we also have minus sine 180 minus 140, which is minus sine 40 degree. Now I say you should take note, adding or subtracting a full rotation, which is 360, to an angle does not change the value of the angle. Let's look at page 13. We have to evaluate on page 13. We have to evaluate the following. You take them as assignment. Sine 160 degree cos minus 400 tan 520, sine minus 200 sine minus 40. That's A, B. If sine theta is 1 over root 3 and theta is obtuse, find cos theta and tan theta. We know the meaning of obtuse. It means that the angle is in the second quadrant. Tan theta is 3 over 4 and theta is in the third quadrant. Calculate sine theta and cos theta. So we have further problems on trig identities. You have to prove those problems on trig identities. So let's look at page 14. On page 14, I discuss complementary angles. So sine theta is cos 90 minus theta. Cos theta is sine 90 minus theta. Sec theta is cosec 90 minus theta. And of course, cosec theta is sec 90 minus theta. Tan theta is cot 90 minus theta. Cot theta is tan 90 minus theta. Let's take an example. If sine theta is 0.5, find cos 90 minus theta. Since sine theta is same as cos 90 minus theta, this implies that cos 90 minus theta is also 0.5. Sine, of course, the example 2, sine 25 degree is same thing as cos 90 minus 25, which is cos 65 degree. And sine 42 degree is same thing as cos 90 minus 42, which is cos 48 degree. Now, cos 84 degree 10 minutes can also be written as sine 90 minus 84 degree 10 minutes, which is sine 5 degree 50 minutes. Now, of course, on page 15, let's look at fractional and third form of trig ratio. Fractional and third forms of trig ratios. In figure 2a above, ABC is an equilateral triangle of side 2 units. All the sides are 2 units because all the angles are equal 60 degree. Now, in that triangle of side 2 units, AD bisects angle A. AD is a line that bisects angle A. Of course, angle A will be 30 now. The side BC using the side BC, AD bisect angle A and bisect the side BC. Divide BC into 2 equal parts. So if BC is 2 units, BD will be 1, DC will also be 1 unit. Using Pythagoras theorem, we want to get AD. AD is root 2 square minus 1 square using Pythagoras theorem. So AD is root 3. So this implies that sine 30 degree, which is opposite, the opposite is 1 and the hypotenuse is 2. So sine 30 degree is 1 over 2 and cos 30 degree is root 3 over 2. Tan 30 degree is opposite over adjacent. The opposite of 30 degree is 1 and the adjacent is root 3. 1 over root 3. Sine 60 is opposite over hypotenuse. The opposite for 60 degrees is root 3 and the hypotenuse is 2. Cos 60 degree is opposite. The opposite is the opposite is for, well, when we talk of cos 60 degree, we have adjacent over hypotenuse. Cos 60 degree is the adjacent over hypotenuse. The adjacent is 1 and the hypotenuse is 2. Cos 60 degree is 1 over 2 and tan 60 degree is opposite over adjacent. The opposite for 60 degree is root 3 and the adjacent is 1. So take note that sine 60 degree is same thing as cos 60 degree and sine 60 degree is same thing as cos 30 degree. Let's look at page 16. On page 16, we have figure 2b. If PQR is an isosceles triangle with PQ equals to QR, and let's assume they are 1 unit each, by using Pythagoras theorem, PR is root 1 square plus 1 square, which is root 2. And sine 45 degree is 1 over root 2. And cos 45 degree is also 1 over root 2. Tan 45 is 1. Take note that cos 45 is same thing as sine 45 degree. Using third form, we are asked to evaluate 3 tan 60 minus 2 cos 30 degree over tan 30. And of course, substituting 3 into root 3 minus 2 into root 3 over 2 divided by 1 over root 3. If you simplify that, you have 2 times 3, which is 6. And of course, on page 17, let's look at page 17. You have to evaluate the following 1, 2, 3 as an assignment. Then we have trigonometric equations. Solve the trigonometric equation 5 sine theta plus 3 equals to 0. For theta lies between 0 and 360 degrees. If you take sine theta is minus 3 over 5, and theta will give us arc sine minus 0.6000. The acute angle for sine 0.00 is 36.87. So the angle lies between the third quadrant and the fourth quadrant, because sine is negative there. In the third quadrant, it will be 180 plus theta, and in the fourth quadrant, it will be 360 minus theta. And you have 216.87 in the fourth quadrant, in the third quadrant, and 323.13 in the fourth quadrant. Of course, let's look at example 2. Solve 2 minus 4 cos square A equals to 0. Theta lies between 0 and 360 degrees. Now the solution, if you solve that, cos A is square root of 0.5000, which is plus or minus 0.7071. A is cos inverse plus or minus 0.7071. Its acute angle, that is cos inverse plus 0.7071, is 45 degrees. Now page 18. On page 18, cosine is positive in the first quadrant, in quadrant 1 and 4, and negative in the negative. It gives a negative in the quadrant 2 and 3. Is negative in quadrant 2 and 3, positive in quadrant 1 and 4. Hence, A is 45 degrees, 135, 225 degrees, and 315 degrees. Of course, in the first quadrant is 45 degrees, and in the in the fourth quadrant it will be 360 minus 45, which is 315. That's positive in quadrant 1 and 4, negative in quadrant 2 and 3. In the quadrant 2, it will be 180 minus 45, which is 135. And in quadrant 3, it will be 180 plus 45, which is 225 degrees. Now, the third example, you have to solve the equation 8 sine square theta plus 2 sine theta minus 1 equals to 0. For theta lies between 0 and 360 degrees. Factorizing or using quadratic formula, we have 4 sine theta minus 1 into 2 sine theta plus 1. If you factorize, you have equals to 0. 4 sine theta minus 1 is 0. Sine theta is 1 over 4. That gives 0.2500, or 2 sine theta plus 1 is 0. When you simplify, sine theta is minus 1 over 2, or minus 0.5000. Theta is arc sine 0.250, which is 14.480, or it could be positive. Is positive. Sine is positive in the first quadrant or second quadrant. In the second quadrant, you have 180 minus 14.48 degrees, and that gives 165.52 degrees. Of course, sine theta is negative in the third and fourth quadrant. So minus 2500 minus arc sine minus 0.500, and that gives the positive value of that is 30 degrees. So in the third quadrant, since it's negative in the third quadrant, that gives 180 plus 30, that is 210. It's also negative, sine is also negative in the fourth quadrant, so that gives 360 minus 30 degrees, and that's why we have 330 degrees there. Hence, theta gives our theta is 14.48 degrees, 165.52, 210 degrees, or 330 degrees. Then you take the student should take the remaining as assignments. So take 1 and 2, question 1 and 2 as an assignment. Of course, let's look at trigonometric ratio 2. Let's look at trigonometric ratio 2. In trigonometric ratio 2, we talk of the general expression for angles with a given trigonometric ratio. General expression for angles with a given trigonometric ratio. If sine theta is alpha, the general solution of the equation sine x equals to alpha is given by x equals to n times 180 degrees plus minus 1 raised to power n dot theta. And of course, if our angle is in radian, so 180 is pi, that gives n pi plus minus 1 raised to power n dot theta. So n is an integer, positive, negative, or 0. E.g., find the solution of the equation sin x is 0.155 for theta lie between 0 degree and 360 degree. Now, let theta be sine inverse 0.515, and that gives 31 degree in the first quadrant. Thus, the general solution is x into, using the formula above, 180 n 180 plus minus 1 raised to power n dot. Our theta is 31 degree. So when n is 0, our answer, the degree is 31 degree. When n is 1, our x is 180 minus 31, using that formula, which is 149 degree. So n is 0, n is 1, we obtain the solution 0 between the range 0 to what? 360 degree. And of course, on page 20, let's look at page 20. On page 20, the equation cos theta equals to alpha. For equation cos x equals to alpha, which is the same thing as cos theta, x is n 360 plus theta, plus or minus theta, or which is also written as 2n pi. 2n pi plus or minus theta if the angle is measured in degree in radians, and n is negative, positive, or integer. There is an integer which is positive, negative, or 0. For the equation tan x equals to alpha, suppose that tan theta is any angle such that theta is equal to alpha. Hence, the general solution is x equals to theta plus n 180 degree, and of course in radian, theta is n pi. Let's take example on this. Solve the equation tan x is minus root 3. If you find tan inverse of minus 3, root 3, the inverse of tan root 3 is, of course, is 30 degree. But because it's negative, theta is negative in the second quadrant. So 180 minus tan root 3, sorry. Tan inverse minus root 3 is 120 degree, is in the second quadrant. The positive tan inverse of root 3 is 60 degree, But because it's negative, minus root 3 is negative, the angle is in the second quadrant. And in the second quadrant, the formula we use is 180 minus theta. Our acute angle is 60 degree, so we have 180 minus 60 degree, that gives 120 degree. That's why theta is 120 degree, because of the negative value. So the general solution is x equals to 120 degree plus n 180. When n is 0 or 1, on page 21, x is 120 or x is 300 degree. And of course, still on page 21, you have to solve, find the value of x if tan 2x plus 3 tan x is 0. Find the general solution together with the solution in the range of 0 to 360 of the equation cos 2x plus sine square x equals to 1. 2 cos square theta minus 3 sine theta, 2 theta minus 2 is 0. 2 cos 3x plus 2 cos 3x, 2 cos 3x cos x equals to cos 2x plus sine 2x plus 1, and tan 2 theta minus 1 equals to 6 cos 2 theta. And that's where we'll stop. Now we'll continue from here next class.